Well, hello everyone. This is Savan, and today we are going to complete our objectives of the day, which are the construction of a DC machine, the classification of a DC machine, and we will discuss about the working principle of a DC machine. So, in the last lecture, we have completed our basic fundamental laws required to understand the working of machines, and I'll presume that you are much aware about basic electrical fundamentals. So, today we have objectives. First one is DC machine introduction. In this, we will classify the DC machine as a DC machine can be taken in work in two parts. One is generator that we call as DC generator, and second one is DC motor. A DC machine can be used in two ways only. So starting with the basic thing and the basic question that comes to your mind, that is, what is a machine? How can we define a machine? So machine is a electromechanical energy conversion device. Electromechanical energy conversion means conversion of energy from electrical to mechanical or electrical to mechanical. Sorry, I think I repeated that. Electrical to mechanical and mechanical to electrical. Same thing. So the machine that converts mechanical energy into electrical energy. This machine is called generator. And the machine that converts electrical energy into mechanical is termed as motor. So now we have idea about what does a generator do and what does a motor do. So we will discuss about working of DC machine. So firstly we will discuss about generator. So let me draw the basic diagram. Suppose this is the North Pole, this is the South Pole. This is armature, or say a coil having two turns. These are commutator and brushes. Two terminals pulled out. Now consider that the poles are having residual flux. Residual flux means they have some flux stored in them, or they have some magnetic field lines stored in them. So see, this is a conductor, and whenever the conductor is placed between two poles of a magnet having some flux and the conductor is rotated, say I am saying the conductor is rotated, like see These are the magnetic field poles, and this is our winding. Whenever this is rotated clockwise or anti-clockwise in either direction, we say, then due to cutting of magnetic field lines, see, these are going like that, like that. Whenever this is rotated, see, these are having magnetic, say these are magnetic poles, and whenever this conductor rotates, it cuts the magnetic field lines or magnetic flux of the poles. As we know, whenever a whenever the flux linking to a conductor, this is a conductor, this is the magnetic field lines, whenever the flux linking with the conductor changes, or the flux linkage or the flux cut down by the conductor, an EMF is induced in the conductor. So this is conductor. Due to cutting down of the flux or magnetic field lines, there is a EMF induced in the conductor, and it has a closed path. Due to closed path, the EMF allows a flow of electrons, that is basically current in the conductor. A current, say I, starts flowing in the conductor. When the the direction of current can be found out by using Fleming's right hand rule: motion, force, direction of current. So, sorry, motion, magnetic field, or direction of current. So this will allow the generation of EMF, and the voltage will be obtained at the terminals. This is the basic principle of working of a DC generator. However, in case of motor, it is quite different. Third one is working of DC motor. In this case, it is quite opposite. Like, this is magnetic pole N, this is magnetic pole S, this is the conductor or say armature, this is commutator and brushes, and this is a DC source or battery, minus plus. So it is V, terminal voltage, I, the current flowing through it, the magnetic field lines. Now the conductor is magnetized by the voltage V, and due to this a current I starts flowing in the circuit, and due to the flow of current, a magnetic field is produced by the conductor. Say, and the direction of magnetic field will be find out by right hand thumb rule. As the direction of current is this, the magnetic field lines rotate like this. So you can check the direction. So the basic fundamental is that whenever two magnetic fields interact each other, a force is applied or generated, or a torque is produced due to interaction of two magnetic fields. the magnetic field of poles and the magnetic field of the conductor interact each other, say this and this, to create torque, which allows the rotation of rotor. This is the basic working principle of motor. Now, moving up to construction, the last topic of the day, construction. Construction of DC machine. Basically, the construction is same for both motor and generator. The difference is whenever we applied the battery source or any energy or excitation to motor or DC machine, the motor works as a motor, and if the machine is rotated or having some mechanical energy, it the same machine can be work as a generator. So the first part is yoke. The yoke is the outermost part of the machine. See, this is a small DC machine which we generally use in our projects and something like that. The outer frame, this to which the motor is covered, is known as yoke. It protects the motor from outer damage. See, like whenever the motor slip from my hand and fall down like that on a rough surface, then it is dangerous for the winding of the motor or generator or a simple DC, any kind of machine. So it is used for the protection. Secondly, it allows low reluctance path for the magnetic flux. The second part of the motor or machine is pole core, pole shoe. Suppose this is a DC machine having the side view. Then there are poles, as we have discussed. Suppose a 4-pole machine. The poles are having two part, one of which is known as pole core and secondly is pole shoe. Pole core is connected to the inner periphery of the yoke. However, pole shoe is mounted on the pole core to house the field winding. The field winding is the one which allows the magnetic field in poles. See, this part is pole core or this part is pole shoe. Now it allows or house the field winding. Now what is field winding? Field winding is made up of enameled copper and it is the winding that allows the formation of magnetic flux in the poles. Now the next thing is armature. This is made up of silicon steel lamination. It is particular reason using that material and lamination is to reduce the or minimize the copper and eddy current losses. Now next is armature winding, which is mounted or have wound on armature core. It is the heart of DC machine or any machine. When it rotates, mainly it is used to cut down the flux or the magnetic field interaction. There can be two kind of armature winding. Let me note the parts. Fourth is armature core. Fifth is armature winding, and there can be two type of armature winding. First one is lap winding and second one is wave winding. In lap winding, number of poles become equal to number of parallel path. As you see, you can see the conductors, see that, and then downwards. I think you can notice them. These are the parallel paths coming from the windings. These are equal to poles, number of poles when it is lap winding, and these are only two for wave winding. The next part is commutator. Commutator plays a major role in DC machine. Firstly, it will allow the conversion of AC power generated in DC generator in DC power. So it works as a mechanical rectifier. There are several segments in this, and also it allows the bidirectional supply obtained from the armature winding into unidirectional supply. Now seventh one are brushes. These connect the commutator, which allows the terminals voltage to let us connect at the terminal box or let us reach the commutator or armature winding so as to get the stationary power. Now after that, the part remaining will be, say, end rings that cover the DC machine from the sides and protect them. Next one is bearings that helps the frictionless rotation, and the next one is lock or nut bolts. 11th one is eye lock, which is used to handling the DC motor. These are the main constructional part of DC machine. So for today we have completed our objectives, which are about DC machine introduction. We classified DC machine as DC generator and DC motor. We acknowledged the working principle of DC generator and DC motor, or the same DC machine as a generator or motor. And after that we learn about construction of DC machine. For today it's enough, and the next day we will try to understand the EMF equation and armature reaction of the DC machine, and we will try to have some numericals on that portion too. For now, thank you everyone.